All right, let's continue our discussion about quadratics, their graphs, which are parabolas, vertices, and some applications. All right, first remember that a quadratic function in standard form is written f of x equals ax squared plus bx plus c, where a is the coefficient in front of the square term, and if a is greater than 0, our parabola opens upward, and if a is less than 0, it opens downward. But in both cases, they have a special point called the vertex. I'm going to label it on both graphs. So that's our vertex for the first parabola, and this is our vertex for the second parabola. Now, a vertex is an ordered pair, so it has an x value and then its corresponding y value. All right? So this is where the x value is where the, let's just come back to that when we talk about it in terms of its application. All right, so it has an x value and it's got a y value. So let's write our vertex formula. So the vertex, given f of x, let me rewrite that up here, f of x equals ax squared plus bx plus c. The first thing you do is find the x-coordinate of the vertex, and you do that by plugging in the b, which is the coefficient in front of the x term, divided by 2 times the coefficient in front of the squared term. And then to find the y value, you just take the x value that you just found and you plug it into your function, and those together, the xy, give you the vertex. All right, so let's consider an example. Let's say we have the function f of x equals x squared minus 6x plus 2. And we're interested in finding the vertex. The first thing is to note the coefficients. So a is equal to 1, b is equal to negative 6, and c is equal to 2. So remember, the signs always are included in our coefficients naming. All right, so to find the x-coordinate, you plug in the negative of negative 6, which becomes positive 6, over 2 times 1. And that becomes 3. So that's the x-coordinate of our vertex. To find the y-coordinate, you're going to plug in 3 into your quadratic, which you have listed right here. So 3 squared minus 6 times 3 plus 2, or 9 minus 18 plus 2, or 11 minus 18, which is negative 7. So that tells us that our vertex for this quadratic is 3, negative 7. Okay, excellent. Now, let's go back here for a second. Notice on these parabolas, so we'll call this one parabola A and this one parabola B. The one A parabola, the one where it opens upwards, what happens at the vertex is the quadratic achieves its minimum value. All right, so it's a minimum value there. Whereas in parabola B, when it opens downward, that is, the coefficient is negative, the parabola achieves its maximum. All right, and so some applications where it's asking you to find a maximum or a minimum and it models a quadratic, then you can simply do that by finding and interpreting the vertex. So having said that, let's look at an example. So assume that somebody is standing on a 40-foot platform and they throw a ball up from the platform and it rises into the air and then falls to the ground. Oops, I kind of overshot the ground a little bit. Let's make that a little bit less. Oops. All right, and furthermore, it's the distance that it is at any time t is given by this formula. We know that the coefficient in front of the square term is negative, so it's a downward opening parabola, and it has a vertex. All right, now let's talk about what's happening at the vertex. So the x-axis is time in this case, and the y-axis is the distance above the ground. That's your d of t. All right, excellent. Also, this is given, distance is given in feet, and we'll say time is given in seconds. All right, excellent. So let's see what the vertex means in context to this problem if we were to find it. Well, let's say this is the t point, and this right here would be the y point. So t d of t is my vertex. And so what happens there is the t is when it achieves its maximum, and the d of t is where. So if I ask the question, what is its maximum height, you would tell me I guess what would be where or what, depending on how you're answering the question in terms of distance, but what the maximum height is, or what the distance above the ground is. If I ask you when it achieves it, you would tell me the t that goes with that corresponding value. All right, so let's find the vertex and then interpret it. So, to find our vertex, we identify our players like before. So A is equal to negative 16, B is equal to 30. Sorry about that. B is equal to 32, and C, which we don't actually need, is equal to 40. All right, so our x value of the vertex is the negative B over 2 times negative A, which is negative 16. And if you see, that becomes negative 32 over negative 32, or a positive 1. So that means the ball will reach a maximum height after 1 second. All right, now to find what that maximum height is, I'm going to plug in, I shouldn't say x, I should say t here to be consistent with the variables I'm using in this problem. So t represents our x value. So d of 1 is going to be what that maximum height is. So I plug it in, negative 16 plus 32 plus 40, and simplifying, you get 56. All right, so that means the vertex is 156. So this is when it achieves it, if that's the question, and this is what it is. What is the maximum height? Now, if another question that I might ask is, when does this ball hit the ground? Well, you can tell just by looking at the picture that the ball hits the ground. That is, when the height above the ground is 0. So when the ball hits the ground corresponds to when d of t, that is the distance it is above the ground, equals 0. So in order to answer that question, you need to set our quadratic to 0 and solve for the t. So let's do that. So we have negative 16 t squared plus 32 plus 40 equals 0. That's how we're going to start the problem. I'm going to simplify because I know that solving quadratics can require factoring or using the quadratic formula, and it's always easier to use smaller numbers. So I see that I can divide everything through by negative 8. That's the largest divisor I can find, including the 0. And that leaves us with 2t squared minus 4t minus 5 equals 0. And I can tell on quick inspection that this does not factor. So I'm going to solve using the quadratic formula. So t equals negative 4 plus or minus the square root of negative 4 squared, so 16, minus 4 times 2 times negative 5, all over twice a, or 2 times 2. All right, this is fine. So this is equal to 4 plus or minus the square root of, so 4 times 2 is 8 times 5 is 40, so this becomes 56 under here, all over 4. Now one of those is going to give us a negative time, which we'll exclude, and so we only consider the positive one, and it's about, if you plug this into your calculator, 2.9 seconds. All right, so when, let me highlight this for us, when the ball hits the ground is after 2.9 seconds. Excellent.